In the previous section, we looked at one example that was dealing with car age and value, so we're going to revisit that example. We talked about the general shape of the scatter plot. We made a prediction. We interpreted our slope and our y-intercept. So now we're going to think a little bit about our coefficient of determination. So we're given, in this case, or we could look up using a table or something along those lines, but just to make it nice and easy, we're given that our correlation coefficient is negative 0.778. This is something else that if you start with just a basic data set, it is given to us in StatCrunch when we are given our equation of our line, and all of the other information, our list of all of those different things in our equation as we're looking at these. So our correlation coefficient is negative 0.778. What does the coefficient of determination tell us? Well, the first thing we're going to do is we're going to find our coefficient of determination. So we're going to take that value and we're going to square it. You can use your calculator, you can just multiply it by itself. Make sure that you are entering these carefully. If you have a negative, you're putting it in parentheses if you're using your calculator, because it should turn out to be a positive value for our r squared. If you end up with a negative value for your r squared, something went wrong. It should be positive. So our r squared value in this case is 0.605. So what we're going to say is we're going to say that the coefficient of determination is 60.5%. And so it's 60.5%. We're just going to take that r squared and we're going to think about it as a percentage. Right? And going back to the previous page, again, our percents are going to be between 0% and 100%. And then we're going to kind of continue to answer our question based off of that percentage that we find. So, car age, our x value, explains about 60.5% of the variation in car value, our y value. So x explains about 60.5% of our y value here. Our regression model, this means because it's 60.5%, right, it's not perfect. Right? Plugging the value of x into the regression line gives us an imperfect prediction about what y would be. Right? So the closer the percentage is to 100, the better prediction we're going to be. In this case, we have about 60.5%. Right? So our prediction isn't perfect. It's an imperfect prediction. So again, when we're answering these questions, we want to be looking at that percentage that we get for our r squared value. All right, we're going to look at one more example. Right. The scatter plots show the linear relationship between height versus weight. Our coefficient of determination is 0.514. And then our waist size versus weight, our coefficient of determination is 0.817. What does this tell us? So we're going to compare these two things together. So our r squared for predicting weight from height is 51.4% if we change that value to a percentage. And then our r squared for predicting weight from waist size is 81.7%. So if we just simply compare these two, even without knowing our equations or anything else like that, and we can kind of see even from our picture, we can explain more variation in weights using waist size than by heights, and therefore we can make better predictions using waist size as the predictor. And our graph, right, it looks like there's a stronger correlation, so that should make sense. Right? So our coefficient of determination is directly related to our correlation coefficient. We can find our coefficient determination by squaring our correlation coefficient, again, or we could go back to our original linear regression types of problems in StatCrunch, and that will also give us our coefficient of determination as well. And then once we have that coefficient of determination, we can use that to either explain how well our predictions are going to be made and or compare predictions from a couple of different data values, a couple of different data sets, a couple of different scatter plots as we're looking at it. Right, so that's going to wrap up our discussion for Chapter 4 and our linear regression line and linear modeling.